Hello and welcome back to ATT STEM. Today we're going to be watching a video about lithium. So, without further ado, let's watch.
Lithium is the lightest metal. We all know that sodium is pretty light as a metal. If you drop it onto water and forget the reaction, it floats.
You can see the orange sodium flame. Oh, it's on your camera. Oh, it is too.
Of course, lithium will do the same, though there are differences which I'll show you in a minute. But what I wanted to see was whether we could demonstrate how much lighter lithium was than sodium. We've never tried this experiment before, but I asked Neil, our technician, to drop a piece of sodium and a piece of lithium of approximately the same size at the same time into beakers of hexane.
The way that this lithium, I'm pretty sure, it looks kind of like cookies and cream ice cream, but I doubt it would taste good.
Hexane is similar to gasoline or petrol, and when he dropped them, it was really striking. The sodium sank like a stone because gasoline is much less dense than water, but lithium bobbed around like a little boat. If you look carefully, they both started bubbling because we didn't use dry hexane, and both samples of hexane contained just a little bit of water that started reacting. And of course that prompted Neil to want to drop the lumps of metal into real water. So we tried the
I bet this is going to explode.
Experiment again, dropping
or something.
Lithium and sodium into water. Of course, this time both of them floated, but lithium is less reactive towards water than sodium. It's a smaller atom, the electrons are more tightly held, and the reaction is slower. With the sodium, it was really quite surprising. It went off with a real bang.
Whoa. It broke
And
the entire
beaker
beaker.
ended up in the back of the fume cupboard. And the sodium was gone. And the lithium quietly buzzed around on the surface of the water, and when Neil encouraged it with a flame, we got a beautiful red colour, the characteristic flame colour of lithium. The other experiment we tried was burning lithium in air and comparing it with burning lithium in nitrogen. N2 has the strongest bond between any two atoms of the same sort in the periodic table. So you need a lot of energy to break them apart. Because lithium is small, it can form very tight bonds with nitrogen. And so I read frequently that lithium will burn in nitrogen. So I persuaded Neil to set fire to some lithium, and it burned really brightly in air, and then poured liquid nitrogen into a beaker to fill it up with nitrogen gas. Nitrogen boils at minus 200 degrees centigrade, or minus 196. So the gas was pretty cold in the beaker, and then he plunged the burning lithium into the beaker. Now here, there was a difference of opinion between me and Neil. I thought the reaction
It looks kind of like an upside-down mushroom.
Was a great success. Neil was a bit disappointed because the lithium just glowed red. But what I saw was this is not a very big piece of metal being plunged into really cold gas, and it kept on glowing red, on and on and on. Whereas if it had just been put out because it wasn't reacting with nitrogen, it would have lost its colour very quickly. So I felt that it was a reasonable demonstration. I've tried to do the same demonstration with magnesium, which is also meant to burn in nitrogen. I demonstrated it for 25 years to successive generations of students and didn't work once. I knew it wouldn't work, but
He showed them an experiment that he knew wouldn't work, Yet he did it for 25 years in a row.
Every time the students thought, stupid professor, doesn't work. Lithium is used for treating bipolar disorder, sometimes called manic depression. This is a very distressing disease which is caused by imbalance of chemicals in the brain, which causes people sometimes to be really manic and other times so depressed that they can't get out of bed. The application which you use probably most often for lithium is in batteries. This is not a new idea. I found an old Scientific American from 1967, and inside there is an advertisement here with a picture of Edison's desk. On his desk, when he died, was a large can of lithium. This is an advertisement from a company that sells lithium, or sold lithium.
Thomas Edison did he use lithium for his light bulbs or something? Or tried to, I guess?
In those days. The reason that Edison had lithium on his desk was that he realized it could potentially make really good batteries.
Is that the known reason, or is that just what Foot Mineral Company is suggesting?
I think that's what they're suggesting. And since he didn't make lithium batteries, perhaps we'll never know. So there's one final and important application of lithium, which is in making hydrogen bombs. Let me just remind you that
Bombs.
An atom bomb is formed by atoms, usually of uranium, though it could also be plutonium, splitting apart. These are called a fission bomb. A hydrogen bomb is inherently different.
The Atomic Energy Commission and the Department of Defense have conducted important tests of an experimental device based on the thermonuclear principle.
Bits come together. So two atoms, for example, two deuterium atoms.
But what is deuterium? I was coming to that. An atom of this kind of hydrogen has the simplest nucleus known. But hydrogen exists in two other isotopic forms. Deuterium, which has a neutron in addition to the proton, and tritium, which has two neutrons and one proton.
Atoms of hydrogen with mass 2, rather than mass 1, come together to form an atom of helium. The first hydrogen bombs that were made, and they really ought to be called deuterium bombs, not hydrogen bombs, involved liquid deuterium. And so the bomb really looked like a small chemical factory because there were big tanks of liquid deuterium, and nobody could imagine carrying this on an aeroplane for actually bombing.
This is the first full-scale test of a hydrogen device. If the reaction goes, we're in the thermonuclear era.
5, 4, 3, 2, 1, 0.
The breakthrough came when...
That's, like, insane. The fact that just by, like, mixing those two gases, or, well, I guess technically it was in liquid form, but just by mixing those two chemicals, you get an explosion that big. It's insane.
When it was realized that you could use the compound of lithium and deuterium. This is lithium deuteride, LID, which is chemically the same as LiH, but with a heavier isotope. What happens with that sort of bomb is that you trigger it with an atom bomb that produces a lot of neutrons, and the neutrons turn some of the lithium atoms into tritium, hydrogen of mass 3, and then the deuterium and the tritium fuse together, giving out energy. Lithium deuteride is a solid which is stable at room temperature. In principle, you could make lithium tritiide, LiT, but tritium is highly radioactive and decays away with a half-life of 12 years, so you have to keep on replacing your bomb. So you could build a bomb without the huge containers of liquid, and you could make something that was still pretty big, but in principle could go in a giant bomber. The first test of a lithium deuteride bomb was carried out, I think, in 1954.
We feel that the report of this important test should give the failures as well as the successes.
The test name was called Castle Bravo.
The date was March 1, 1954. This photograph was taken from an airplane at 50 miles. The width of the fireball at this time, about 3 seconds after detonation, was 4 miles.
And it was really too successful. The power of the bomb was 3 times bigger than had been calculated.
Tremendous yield resulted in a serious fallout situation at Bikini and certain other atolls downwind from ground zero.
The residents of the islands nearby had not been evacuated far enough, and several people were exposed to radiation
That's
in a most
like
unfortunate
horrible.
manner. But the principle was demonstrated. Of course, the whole technology is horrific, but it's interesting to see how lithium played a part. But to end on a much happier note,
Why don't people use hydrogen bombs or deuterium bombs? I think you call them. But why don't they use them in like wars or stuff? Because it seems like they'd be pretty efficient.
lithium is a light metal. Hydrogen can be used to fuel cars using fuel cells that convert hydrogen to electricity. So now there is a lot of research to see whether lithium hydride or a derivative of lithium hydride can be used to store hydrogen in the tank of your car.
Thanks for watching. Stay smart, and we'll see you next time. Bye.